Welcome back to GateX AIML. So the next discrete probability distribution that you are going to learn is Poisson distribution. Let us understand the concept. So a Poisson distribution model for a Poisson process. What is the Poisson process? Actually it counts the number of occurrences of an event in a fixed time interval or region. For example, number of buses arriving in a given time, number of bacteria that grow in a given region. Okay. So time interval or region, something like area, volume, distance, etc. will be given, or something arriving in a minute, in an hour, day, some time quantity or region is mentioned. So that can be modeled using Poisson process. For example, number of phone calls received per hour. So in a call center, number of phone calls they receive in an hour. Number of school closures due to snow per winter. Number of baseball games postponed due to rain. If you observe here, see events are dependent on time or region or area, something like that, in a given particular time or in a given interval or a given region, given area, like that. Number of field mice per acre, that is number of the mouse you see, that eat up in your fields. Number of bacteria in a culture. Number of typing errors per page. So per something you have per unit, per page, per unit of time, per area, like that. Now it is very important to understand this properties of Poisson process. So you know that these properties are met, then the data follows Poisson's process. Then you can apply the Poisson distribution. The first one is independence. Events in non-overlapping intervals or regions are independent. So for example, say that what is this first point says? It is saying that, see, you go to a mart, say some mart, for buying some items, right? People arriving between say 11 a.m. to 12 noon is independent of people arriving from 5 p.m. to say 6 p.m. This is 1 hour interval. This is also 1 hour interval. But this is independent from this. That is the independence of events. Second one. This is very important, very important for Poisson distribution. Proportionality. Probability of a single event in a small interval by region is proportional to its size. So as the size increases, the probability of that event also changes. What you mean to say? Suppose say that in a given time, so in the same mart, from 11 a.m. to 12 noon, let us take the same hours. Say 6 people visit. 6 people visit. Now, for 24 hours, that is one day, 6 people per hour. This is important. This is the interval. So in 24 hours, what? See, I'm increasing the proportion, right? Proportionality. From 1 hour, I'm increasing to 1 day, that is 24 hours. So it also increases. The average 6 people visit in 1 hour, then in 24 hours, 6 into 4, right? So 24 people may visit. That is how it increases. So when I solve the problem, I will again explain how to calculate that parameter. Next, negligible multiple events. Probability of more than one event in a very small interval is negligible. So for example, same example. So 6 people, average 6 people in 1 hour. If I say in 1 minute, so the probability of people coming in 1 minute is negligible, right? It is very negligible. So that is what it says. Negligible multiple events means 2 events cannot occur in a small interval of time. Then it can be a Poisson's process. Now let us see the Poisson's mass function, probability mass function. Let x equal to number of occurrences in interval by region. This is important. Then x follows the Poisson distribution with probability mass function given as this. P of x equal to x, there is a parameter called as lambda t. You'll understand what is this lambda t means. That is equal to e power minus lambda t into lambda t to the power x divided by x factorial, where x takes the values from 0 to infinity. Mu is given is equal to variance, both are same here. Lambda t is the rate parameter or the parameter. Now how to calculate this parameter? This comes from directly from this proportionality. That's why I told you it's very important. See, lambda is always given in terms of say some value per interval or region, per interval of time or region, per some unit. Okay. This t indicates actual time in, that is the proportionality, actual proportionality. That means say lambda equal to, say if I say 3 buses arrive per hour in a bus stand. Okay. That means if they say in a day, so t becomes 24. So in that case, you have to multiply it 3 into 24. So lambda t becomes different. Okay, once you solve the problem, you'll understand. Now, how to identify a given problem can be applied Poisson distribution. See, they'll mention fixed time, that is interval, area, volume, or distance. Some rare events, average rate known, rate, counts of events, not continuous measurements. Events are independent. Common phrases, on an average 10 buses arrive. So per unit of time, exactly X event in a given time by region. Okay. So try to understand this clearly. When I explain the exponential distribution, again the same rate parameter comes, but that is there's a different way to identify that. Okay, now only I'll give a caution. So exponential distribution and Poissons are a little bit confusing as they are from the same family of the distribution. That's the reason they are a little bit similar, but not exactly same. They follow something else. This follows something else. So when I explain exponential, I'll again explain and compare with the Poisson. So now for time being, Poisson means these are the keywords you have to look for. Okay. Now let us take some simple examples. On an average, 8 airplanes land at a regional airport each hour. 8 airplanes each hour. So time is mentioned. So it follows Poisson's. The airport has 10 runways available. What is the probability that in a given hour, more than 10 airplanes attempt to land? Okay. Let us first write the Poisson distribution. This is written as is equal to lambda t to the power x into e power minus lambda t divided by factorial. Now let us try to find these parameters first. So this is what I have to find. What is lambda and what is t here? Lambda is equal to 8 aeroplanes, airplanes per hour. This don't miss. If you miss this, then you will land in trouble. You will get a different answer. T is equal to what? In an hour they are asking. Given hour. What is the probability in a given hour? So T is 1 hour. So that implies lambda T is equal to 8 into 1. This hour and this hour get cancelled. So lambda 2 should be a constant, right? It's a value. So 8. Now what they are asking? P of more than 10 planes. That means P of x not equal to 10. They are saying x greater than 10. This is nothing but what? 1 minus summation of, or you can write 1 minus P of x less than or equal to 10. Because greater than 10 means less than or equal to 10. So this is nothing but CDF, right? So this is 1 minus P of x less than or equal to 10 means what? How will you calculate? This is a CDF you have to calculate. Starting from x equal to 0 to 10 is the e power minus lambda t into lambda t to the power x divided by x factorial, where x takes values from 0 to 1. This is 1 minus summation of x equal to 0 to 10 e power minus lambda t is 8 into 8 power x divided by x factorial. In the exam, will not ask the big value, or they may give something options like this directly. So this is the answer. Next, a bank receives an average of 15 customers per hour, lambda equal to 15 per hour. Don't forget to write this. There are only 12 service counters available. What is the probability that at least 16 customers, at least means x greater than or equal to 16, you have to find out. In a given hour, again, t is equal to 1 hour. So that implies lambda t is equal to 15 with no units. Okay. So this will be x greater than or equal to 16 means 1 minus p of x less than or equal to 15, right? But 16 is included here. This will be 1 minus summation of x equal to 0 to 15 e power lambda t is minus 15 into 15 to the power x divided by x factorial. This is the answer. Next, a factory produces screws with a defect rate of 0.03 per screw. A shipment contains 1200 screws. What is the saying? Lambda is equal to 0.003 per screw. Now you see here why you should write this. Now they are saying shipment contains 1200 screws. Okay, that means 1200 is T here. Otherwise, some people who don't write like this will get confused and will directly take lambda T as 0.03 and you will get a wrong answer. So that implies lambda T is equal to 0.003 into 1200 screws divided by per screw. No screw get cancelled units. So this comes to be 3.6. They are asking probability that more than 5 defective screws are found. 5 defective means x is more than 5, x greater than 5 is equal to 1 minus p of x is less than or equal to 5. Okay. This is 1 minus summation x equal to 0 to 5 e power minus lambda t is 3.6 into 3.6 to the power x divided by x factorial. This is the answer. Next, buses arrive at a city station at an average rate of 3 buses every 6 hours. Oh, see here, lambda is what? 3 buses per 6 hours. The station can accommodate at most 18 buses per day. What is the probability that on a given day buses will have be turned away? See, T is what? 1 day. That is 24 hours. So what is lambda T? That is the reason I told you write like this. Lambda T is equal to 3 by 6 into 24 hours. This hours get cancelled. This will be 12. Lambda T is 12. Now you find out it can accommodate at most 18 buses. So at most means less than or equal to 18. So you have to find P of x greater than 18. This is 1 minus P of x equal to 18. X is less than or equal to 18. So this comes out to be 1 minus summation of x equal to 0 to 18 e power minus lambda t is 12 into 12 power x divided by x factorial. Okay, so be careful in this problem. This and this, how you calculate from the data is important. So in the next class we will start with the discrete uniform distribution. Thanks for watching. Please like, subscribe and share with your friends. Thank you.